we know that the magnitude of the gravitational force between two bodies m1 and m2 is calculated as follows. This means that the magnitude of the gravitational force that the two bodies exert on each other is equal. If two celestial bodies m1 and m2 orbit each other with orbital velocities v1 and v2, the following centrifugal forces result. The velocities mentioned here refer to the velocities of the two bodies without the influence of other external forces, i.e., to the velocities in a circular orbit. The prerequisite for two celestial bodies to revolve continuously and stably around each other is that their respective centrifugal forces are equal to the gravitational pull of the other celestial body. Furthermore, the centrifugal force of any body is exactly equal to the gravitational force that body exerts on another body. In general, centrifugal force and gravity are two completely different concepts, yet they are very closely related. We consider the gravitational force from m1 to m2 and from m2 to m1 as follows. Since F1 equals F2, the condition for the existence of such a system, in which the two bodies orbit each other, is that their two gravitational constants must be equal. Since their centrifugal force is equal to their gravitational force, for example for M1, then the following holds. From this, we obtain. This means that the gravitational constant of a body depends on the mass of another body, on its own orbital velocity, and on the distance between the two bodies. The same applies to M2. In general, two celestial bodies have different masses and different orbital velocities, so their gravitational constants should also be different. However, for such a system to exist and function stably over the long term, they must be equal. The probability that these two gravitational constants satisfy these conditions simultaneously is extremely low. This means that such a case can only occur by chance. From these two equations, it follows that the gravitational constant between two bodies must be as follows. It is proportional to the square of the velocity of any one of the two bodies, proportional to the distance between them, and inversely proportional to the mass of the other body. Furthermore, under such random circumstances, the magnitude of this gravitational constant cannot possibly be absolute. That is to say, it is not a constant. The gravitational constant is therefore not a universal physical constant, but applies only to a specific system. Of course, we cannot assume that all binary star systems and similar systems in the universe formed under the same random conditions. And the commonly accepted value g essentially applies only to our solar system. It is even questionable whether this gravitational constant applies to our Milky Way at all. Such a sovereignty system, consisting of two objects, is not subject to any restrictions regarding their mass, their distance from one another, or their orbital velocity. That is to say, they could be two galaxies, but they could also be two microscopically small particles. Since the speed of microparticles is extremely high and their mass is extremely small, the gravitational constant in the microcosm is extremely large, so that the forces of nature between them are also extremely large. I would like to emphasize once again at this point, force arises from motion. This is one of the fundamental principles of real physics. Gravity, however, is a long-range force that acts between two bodies without contact and without any medium. This is a phenomenon that is difficult to explain.